In this particular lecture session, we are going to see moment of a force. Okay. Let's say a block is resting upon a table, and if we apply a force like this, say F, now what you will observe in this case, you will observe that this force will make the block to move like this. Alright? That means the block is displacing, the force is displacing the block, and this kind of motion we call it the translational motion. So the force is translating the body from this position to another position. Now let's consider another case where you have a nut like this. A bolt together with a nut. Now we may have to tighten this nut or loosen it. Now in order to do that, what do we use? We use a spanner. I am drawing a spanner like this. Okay. Now in order to tighten it or loosen it, we may apply force in this direction or in this direction. Now here also force is acting. Now what you will observe in this case, here you don't observe any translational motion as in this case. Instead it will try to, the spanner will try to rotate under the action of force about this point, right? So here we observe rotational motion. If the force is like this, where the body is free to move, then it will cause, the force will cause translational motion, whereas if it is fixed like this, a bolt or a nut, and we apply a force at the other end of a spanner, the entire spanner together with the nut, they will rotate. This is called rotational motion. Now this rotational effect of the force is measured by a physical quantity which we call as the moment of the force. So moment of the force or F force is nothing but what? The rotational effect of a force. That's what we try to mean by moment of a force. This is also a physical quantity, just like we saw in the initial stages. What are the various physical quantities which are required to describe the state of rest or of motion of a body, and this is one such physical quantity. And we also saw that moment of a force is a vector. Okay. A vector will have both magnitude as well as direction. And when we studied the concept of a force, just concept of force, we listed down the force characteristics like magnitude, direction, the point of application, and the sense of the force. In the same manner, in order to define the moment of a force, we have to define certain things which are called the characteristics of the moment. First of all, it is a vector. Let's take a general case where it is just a body which is pivoted here, okay, and we are applying a force like this on this body, and this will be what? The line of action of the force. Now how to find the moment of this force about this point, because this force will try to rotate it about this. Now this one we call as the moment center. It is nothing but the point about which the body is going to rotate. And in addition, it will rotate about an axis. The entire body will rotate about an axis, and that axis will be like this. If this body is going to lie in this plane of the board, then the axis will be normal to the plane of this board. That we call as the axis of moment. Now we have to define the moment. Now this is what this one entire thing is, line of action, and the point at which it is going to act is what? This is the point of application of the force. And this is what? The line of action of the force. From this point, if we try to represent the position of this point, that is point of application of the force, using a vector, this one is called the position vector of this point, which we call as R. Okay, R vector is nothing but the position vector of the point of application of the force. Then moment is defined as, moment is also a vector, and it will be equal to R vector cross F vector. If you try to recollect what you would have learned in maths at school level concerning vectors, okay, vectors, there are two kinds of multiplication or products. One is dot product, the other is cross product. Since moment of a force is a vector, cross product of two vectors will also be a vector, and you get the magnitude of the moment as what? Rf sin theta, where theta is the angle included between the positive sense of the two vectors. Now the positive sense means, if you extend this, this is the positive sense, so this angle is called theta. Okay, and what will be this angle? This angle is also theta. If then let's try to draw a line perpendicular to this. Let's say this is 90 degrees. Then this is R, this is theta. Opposite side is what? R sin theta. So F R sin theta we can write, and this perpendicular distance, instead of R sin theta, let's call that as D. Okay, so moment of the force, the magnitude of moment is what? F times D. Now what is F? It is nothing but magnitude of force times perpendicular distance of the line of action of the force from the axis of rotation. This is what we define as the magnitude of the moment. Okay, F is magnitude of the force, and D is the perpendicular distance of the line of action of the force from this one. Okay, now you know that the direction of this vector, that is vector product, will always be perpendicular to the plane containing two vectors. So in this case it will be perpendicular to the plane. In general, R vector and F vector may be inclined in any manner, but since we are dealing only with coplanar forces, Okay, here afterwards we will avoid vector and we will use only sign convention. Now what do we mean by that? R vector is going to lie on the board, the plane of the board, and F vector is also going to lie on the plane of the board, and in such a case M vector, the direction of M will always be normal to the board or perpendicular to the board, and that way we have avoided the vectors. Only for defining it we use the vector. Here afterwards we will say moment of a force is what? The magnitude of the force times the perpendicular distance of the line of action of the force from the axis of rotation. Now what about its direction? This force is going to rotate this body in this direction, in the anti-clockwise direction. So we represent the moment like this. In some cases, if the same body is pivoted here and a force is acting like this, then in which direction the force is going to rotate the body? It is going to be in the clockwise direction. So here afterwards we will not use vector, we will use only whether it is clockwise moment or anti-clockwise moment. And as per sign convention, anti-clockwise moment will point away from the board, okay, whereas clockwise moment, the axis, it will point into the board. Since it is pointing away from the board, anti-clockwise moments are treated as positive and clockwise moments are treated as negative. So we have defined what? The magnitude of the moment. We have also defined the direction of the moment, whether it is clockwise or anti-clockwise. This way we have defined the moment completely. Before going further, let's try to see when the moment of a force will be maximum. Now before that, let's see where are the instances where we are using this moment principle. Say there is a door, okay, it is viewing from the upside. Now if you want, this is the place where it is hinged, and when you open the door, what do? You apply a force like this. Then it causes rotation of the door, okay, or same thing in the case of spanner or any other thing. We are going to apply a force and it will cause rotation of the body. This rotation, which we call as the moment, the rotational effect of the force. If I apply the force at the hinge of the door, will there be any rotational motion of the door? You can try it. There won't be any rotational motion. As a result, whenever the force is going to pass through the axis of rotation, moment is zero. This you have to remember. Moment is zero when d is equal to 0. When the force is going to pass through the axis of rotation, then d will be perpendicular distance from the line of action to this point is 0. As a result, moment will be 0. Now suppose we want to apply a force here and try to open the door. Then what will happen? We have to apply more force. The reason is moment is force times d. When d is reduced, instead of placing the force here, I am applying the force here. D is reduced. As a result, I will have to apply more force in order to turn the same thing. This is the d in this case. Whereas when I try to apply the force far away from the hinge or the point of axis of rotation, then this d will be small, greater. When d is becoming greater, f can become smaller. This is the reason why we try to apply force towards the end of the door to easily open the door. In the same way, in the case of spanner, we try to apply force at the end of the spanner, not here. If you apply it here, you will have to exert more force. So for a given force, M is maximum when it is maximum when force is applied at the extreme point. In addition, we will have to apply the force normal to the axis of this member. Suppose we apply the force like this, then the moment will be reduced. So for maximum moment value, we have to apply the force far away from the axis of rotation, plus you have to apply it perpendicular to the member. This will give you the maximum force. Okay. Next, we will see what is meant by Varignon's theorem. Now, what is meant by Varignon's theorem is, suppose you have a force which is acting like this, and this is the point about which it is going to rotate. Sometimes this perpendicular distance of the line of action of the force from the axis of rotation, we may not be easily find out. In such cases, we have to use what is called Varignon's theorem, which is also called a principle of moments. The theorem states that the moment of the resultant of a system of forces about the pivot point is same as the sum of moments of individual forces about the same pivot point. Now, what is meant by that is, suppose you have several forces which are going to act upon at this point, F1, F2, F3, and all these forces will cause a moment about the pivot point, right? And if you sum it up, that moment will be same as the moment of the resultant. This is equivalent to what? Replacing the system of forces by a single force which we call as the resultant about the same point, and this, let's say this is resultant. The theorem states the moment of the resultant about this point is same as the sum of moments of all these forces about the same point. And using this thing only, it will be convenient to find the moment of any force in a simpler manner. For example, suppose you have a body, okay, a force is inclined like this. Now, instead of finding the moment of this force about this point, what we will do is we will resolve this force into components. Okay, since we have resolved it, this force we are not going to consider. Now, once you find the component, this is F, this is theta min, this is F cos theta, this is F sin theta. The moment of this one about this point is 0 because the line of action is going to pass through the axis of this. And what about the moment of this component? It will be just the perpendicular distance, which is L, the length of the member. Whereas if you want to find the moment of this, it will be difficult to calculate the d value. This is the reason why we resolve the force and we are able to follow this. The moment of the resultant is same as the sum of the moments of the system of concurrent forces. That's what we are following while we are applying the Varignon's theorem. Shall we try these revision questions for the lecture that we learned in this? The first question reads, the magnitude of moment of a force about a fixed point is equal to the product of the force and perpendicular distance between, what you have to fill here. So a body is here and this is the pivot point about which the body is being rotated by the force. If this is F, this is the line of action of the force. So magnitude of moment is what? Product of force times the perpendicular distance of what? It is nothing but the line of, if you try to recollect what we studied, it is nothing but the perpendicular distance of the line of action of the force from this, or in other words, the perpendicular distance between line of action of the force and the pivot point. That's what we call as the moment of the force, magnitude of the moment of the force. Next, SI unit of the moment of force. M is this. How to find out the SI unit? You know the SI unit of force is Newton, and D is the perpendicular distance. Perpendicular distance is nothing but a measurement of length. So you have SI unit for length as meter, and so SI unit for moment is what? Newton meter. And this is the correct option, all others are wrong. A force of magnitude, this is the third question, a force of magnitude 10 Newton is applied at the end of a pipe wrench. So pipe is here, wrench will be looking like this. Okay, you apply a force of 10 Newton and this length they are giving it as how much? 25 centimeter, and it says it is applied normal to the length. That means this is 90 degrees. You have to find the magnitude of the moment. What is magnitude of the moment? Force times the perpendicular distance. Force is 10 Newton, force times the perpendicular distance is the magnitude of moment. Force is 10 Newton, which is given in SI unit, whereas the dimension is given in non-SI unit. You have to convert this to SI unit. 25 centimeter divided by 100 will give you the D in meter. Okay, so this you can remove it, and what you will have is 2.5 Newton meter. So this is the magnitude of the moment. Okay, now coming to here, problem number 4. Here also kind of rod is there which is pivoted about this point, and a force of 100 Newton which is acting horizontally is acting, and we have to find the moment of this force about this point. In order to find the magnitude of the moment, you need the magnitude of the force as well as the perpendicular distance. What is the perpendicular distance here? You extend this. Now what is this? This is nothing but the line of action of the force. Now from here you have to find the perpendicular distance. Okay, if this is 60 degrees, this is also 60 degrees, and this hypotenuse is what? 1 meter. Opposite side is what? Sine. So, right, 1 meter sine 60 degrees. So this perpendicular distance is what? 1 sine 60. As a result, the magnitude of the moment is 100 times this perpendicular distance, this perpendicular, it's all same. It is 1 sine 60, and sine 60, when you perform this, it will be 86.6 Newton, or it will be what? Root 3 by 2, right? This will be root 3 by 2 sine 60, 50. So this will be 50 root 3. You can evaluate. I think it will come somewhere around 86.6 Newton or so. You can check it. So you can write this value here, 50 root 3 Newton meter. And with that, we are completing all the questions, and that concludes this lecture session.